In this lesson, we're going to talk about how to set up and analyze simple autoregressive moving average models, which are a very popular tool in time series analysis. Before we begin, let's create a couple random data sets. So I'm going to create a cumulative series of random data, but I'm going to add it to the number 80 to sort of give it a base price that it's going to start with. Capitalize the P in my variable name, price. So here's our fake price series. So this can be a price series for any good or service. It could also be daily temperatures, number of items sold, etc. The list of possible time series is really endless. Now the plot shows us that the time series is not very stationary because it has a changing average. For an ARIMA model, we need to give it a stationary time series, otherwise there will be a serious bias in the model. So we're going to create a new series called price change. And we're going to apply the diff function, which is going to difference the series of our price series. Now the changes are random and bounce around 0 since we used our norm to create the variable. This means that we want a difference parameter of 1 for our ARIMA model. Now I'm going to introduce the adf.test function, which runs an augmented Dickey-Fuller test to see if this is accurate. So we're going to run an ADF test on our as.numeric price series. Let's find out where that function exists. We can load that package. Let's try the double question mark. It's in the T-series package. So we need to make sure we have that installed and we need to load it. The price series is not very stationary as we're left with a high p-value. We'd want a low p-value, something below 0.05, to say that it's stationary. Now if we run the same test on our price changes series, we'll get a little different result. So we received another error because we know that there is at least one NA in our price change series. Whenever we use the diff function, the first observation is going to have an NA. So I'm going to wrap that inside of an NA.omit function. This looks much better. Our p-value is now 1%, and we can safely say that this series is stationary. And also, I used the as.numeric on the time series to remove the timestamps and get faster results. So now we know we will want a difference parameter of 1 in our ARIMA model. So let me show you how to construct that ARIMA model very quickly. So we're just going to assign it to the variable model1, and the function ARIMA uses a couple arguments. Most importantly, the data set that we want to explore, and then an argument called order, which takes in a vector of 3 numbers. The order argument tells the function how many orders of autoregressive terms, how many differences, and how many moving average terms the model needs to include. And when you look at the model, it's going to give you the coefficients for each of the orders of autoregressive and moving average terms after it's already differenced the series. And if you use the summary function on the model, you'll see that it will output for you all the different attributes of that model. Now let's create the same model again, except we won't throw in a difference term. I accidentally overwrote model 1, so I'm going to re-execute the line to create model 1 using the order of 1, 1, and 1. And then for model 2, we're going to use a 0 for the difference term. The AIC between the two different models, 560 for the first one and 570 for the second one, are roughly the same, and the AIC explains how much information the model is capturing. You can think of that as the quality of the model. Another thing to notice between these two models is that for the first one, when we difference the time series, both of our coefficients are very statistically significant, the autoregressive term and the moving average term. However, when we don't difference the series, the autoregressive term stays significant while the moving average term changes quite a bit. So in this lesson, we discussed how to create an ARIMA model using the ARIMA function. It's pretty straightforward and simple, and there also exists a function called auto.arima, which will help you find the most significant order to use for the ARIMA model. And that comes from the forecast package.